Today we're going to finish up lesson 11.3 and lesson 11.6 from start to finish on cones and spheres. So first we're going to finish up 11.3 on the lateral and surface area of cones. Then we're going to do 11.6 on spheres, where we're going to talk about the definition of spheres and their associated vocabulary, then talk about the surface area of spheres, and finally the volume of spheres. So that your objectives, that by the end of the day today, you will be able to find the surface area of cones and both the surface area and volume of spheres. The cone is a 3D figure with one circular base and a vertex, and cones are everywhere. Dunce hats or party hats are cones, traffic cones are cones, and of course everybody's favorite cone is the ice cream cone. But you'll see in all of these examples, they have a circular base and all the points come up and meet at the very top at the vertex. Right. When you're visualizing cones, when you're doing the surface area of cones, it can be helpful to visualize a net of the cones. So if I have this cone here with a radius of, or excuse me, if a diameter of 28 and a lateral height of 29.5, if I were to make a net of that and sort of flatten that out, you can see that I have that on the left-hand side, the base of the circle of 28, and on the right-hand side is the lateral area. That's that odd-looking shape, looks kind of like half a circle, but not quite, with a side of 29 and a half. Okay, let's go back to our notes for 11.3 and continue taking notes. So a cone is a 3D figure with one circular base and a vertex. The base is always a circle. A right cone is a cone where the altitude is perpendicular segment from the vertex to the center of the base. The vertex is just that tip of the cone. The altitude is the perpendicular segment from the vertex to the center of the base. And the height of the cone is just the length of the altitude, which we will abbreviate as just h. The slant height or lateral height is the distance from the vertex to a point on the edge of the base, and we'll call that L. And then, of course, using the Pythagorean theorem, we can find L because r squared plus h squared is going to equal L squared because it makes a right triangle. Finally, the formulas that you'll need for the lateral area of a cone, that's equal to just pi RL. And the surface area, of course, I would just take that lateral area of pi RL and add on the area of the base, like any circle, pi r squared, to get a total of pi RL plus pi r squared. Right, take this down in your notes and then press pause and see if you can do the example problems coming up. And then after you try the example problems, press pause again and go through the answers to the example problems and see how you did. Let's take a look at problem 3A. It's asking us to find the lateral area of the cone and leave our answer in terms of pi. All right, well, we know the lateral area of a cone. A lateral area of a cone is just going to equal pi r L, where r is my radius and L is my lateral height. Okay, so my radius I can find right here, that right here, this line right here is the diameter, and that is 12 centimeters long. And I want the radius. I want half of that. I want the part that goes from the center here to this point here. So that's going to be half of the diameter. So the radius, if the diameter is 12, then the radius is going to equal 6 centimeters. So my radius is going to equal 6 centimeters. My lateral area, I'll draw it right here, is right here. And I don't know what that is. That's what I need to find out. That is my lateral area. But I can draw that I have a triangle. I'm going to draw the height right here. and I'll draw it over here. So I've got right here is the height, right here is the radius, and right here is the lateral height. So once again, this is going to be the lateral height, this is going to be the radius, and this is going to be my height. Okay, and the height we know is equal to 8 centimeters, because it says right here, this is real. The height is 8 centimeters. The radius is 6 centimeters. And the lateral height, that's what I'm trying to find. And of course, I see that this is a right triangle. You can see right here, it's a right triangle. So I know that a squared plus b squared equals c squared. Or in this case, h squared plus 6 squared, 6 centimeters squared, is going to equal, in this case, what we want is L squared. Whoops, I should go back, sorry. If we're going to call that 8, okay, so we've got 8, so that's going to be 8 centimeters squared plus 6 centimeters squared, and that's going to equal my lateral squared. So that would be, if I do this out, that would be 64 square centimeters plus 36 square centimeters would equal L squared. So that's 100 square centimeters must equal L squared. If I take the square root of both sides, I get that L equals 10 centimeters. So actually, we'll do that in blue so we can see it, that L equals 10 centimeters. Okay, so all this was just to find that L equals 10 centimeters. Let me point out that you could have done this a lot easier if you remembered that we have a particular kind of triangle. I'll do it in a different color here. A special kind of triangle called 3, 4, 5. Right? We've talked about this, that this side here is 3 times 2. This side is 4 times 2. So 4 times 2. So this side must be 5 times 2. What is 5 times 2? That's 10. So I could have done all this in just 1 second if I had realized this is a 3, 4, 5 triangle. If I didn't, I could have done the Pythagorean theorem. But in either case, I end up with my lateral height of 10 centimeters. So now I can finally solve it. I know that my lateral height, or my lateral area of my cone, is going to be equal to pi times 6 centimeters times 10 centimeters. Put that all together, multiply that out, and I'm going to have it that's equal to 60 pi square centimeters. That's going to be my lateral area of the cone. Look at part B of this problem. It's asking us to find the surface area of the cone, and again, leave it in terms of pi. And the surface area of a cone is going to be equal to the lateral area. Here, I'll do it in colors here. It's going to be equal to the lateral area of the cone plus the base of the cone. From our previous problem, we found out that the lateral area of the cone is equal to 60 pi square centimeters. So we just need to find the base of the cone. And to find the base of the cone, of course, is a circle. So like any circle, the area is pi r squared. We need to find r, and r is from here to here. If the entire diameter is if the entire diameter is 12 centimeters, then the radius is going to equal 6 centimeters. So the base is going to equal pi times 6 centimeters squared, which is going to equal pi times 36 square centimeters, which is going to equal 36 pi square centimeters. So now we can go back and we know the surface area of the cone is equal to the lateral area, which in this case is 60 pi centimeters squared, plus the base of the cone, which in this case is equal to 36 pi square centimeters. Add that together, and we get that that's 96 pi square centimeters. That's the entire surface area, the lateral area and the base added together gets us the surface area of 96 pi square centimeters. Problem number 4 is asking us to find the surface. If it tells us that the surface area of a cone is 16.8 pi inches squared, and it gives us the radius, and so it's asking what is the slant height. Okay. Well, the surface area of a cone is equal to, as we just said, 16.8 pi square inches, and the radius is going to equal 3 inches. And we also know the formula for the surface area of a cone is equal to pi RL, that's the lateral area, plus pi r squared, that's our base. And now if we know the surface area is equal to 16.8 pi, and the surface area is equal to pi RL plus pi r squared, then through the transitive property, we must know that 16.8 pi square inches must equal pi RL plus pi r squared. And we know that r is 3, so let's rewrite that as 16.8 pi square inches is going to equal pi times 3 inches, there I'm just substituting in my r, times L, plus pi times 3 inches squared. So that's 16.8 pi square inches is going to equal 3 pi L inches plus 3 times 3 would be 9 pi, an inch times an inch would be a square inch. So now if I subtract 9 pi square inches from both sides, whoops, sorry, that wasn't right. Let's do this. What did I just do? Okay. So do this one, that would get me 7.8 pi square inches. And that's going to equal, these are going to cancel. So 3 pi L inches. If I divide both sides by pi and both sides by inches, I end up the pi's cancel, that inch cancels, the square cancels, so I'm left with 7.8 inches equals 3L. I'm going to rewrite that up here. 7.8 inches equals 3L. If I divide both sides by 3, I get that L equals 2.6 inches. So that's how big my lateral height is 2.6 inches is my lateral height. And I found that by just plugging the formula for my surface area of a cone and what the actual value was, plugging that in, and then just solving for the missing variable of L. Now let's talk about 11.6, the sphere. We all know what a sphere is. A sphere is a three-dimensional object. It's shaped like a ball. Right? We see spheres all the time in everyday life, not only balls, but oranges are an example of a sphere. A Christmas ball or Christmas ornament is an example of a sphere. Planets and stars are examples of spheres. Spheres are analogous to a circle. A circle is made up of every point on a plane that is equidistant from a central point. So again, if I take that central point and I take all the points on a plane that are that radius distance away and draw them all, I draw a circle. Similarly, if I do that same thing but don't limit it to a plane, I do it in all three dimensions. A sphere is every point in all three dimensions that is the same distance, again the radius, from the center. And hopefully you can see that from this picture here. The center is that point labeled C that's green in the middle there. And then the sphere is all the points that are a radius distance away in all three dimensions from that point C. And when you do that, it makes something that looks like a ball. Okay, let's go through our definitions we need for sphere, starting with sphere itself. That is the set of points in the space equidistant from a given point called the center. The radius is the segment that has one endpoint at the center and the other on the sphere. So it's the distance from the sphere, from the center of the sphere to any point on the sphere. A diameter, like a circle, is equal to 2 radii. And the definition is the segment passing through the center of the sphere with the endpoints on the sphere. The great circle is that when a plane intersects with a sphere through the center of the sphere, that creates the great circle. And it's kind of like the equator. If you think of a globe as a sphere, and the latitude lines as they move north to south are all circles, but only the equator is the biggest one. Only the equator is the biggest circle you can get by intersecting a plane with that sphere, and that's why it's called the great circle. It's the biggest the biggest circle you can get within a sphere. A hemisphere is simply half a sphere. When we talk about the circumference of the sphere, we're really just talking about the circumference of the great circle. Those two things are equivalent. And now finally, the formulas. So the surface area of the sphere is just equal to 4 pi r squared, 4 pi times the radius squared. And of course, spheres don't have a lateral area because they have no base. And then finally, the volume of a sphere is equal to 4/3 pi r cubed, or 4/3 pi times the radius cubed. All right, push pause and get all these definitions down in your notes, and then try the example problems. After you've tried the example problems, push pause again to go through the example problems and see how you did. So when I look at this one, I can see right here that the radius of this sphere right there is 5 centimeters. So I see that the radius equals 5 centimeters. All right, and I'm supposed to find the surface area. All right, the surface area of a cone, a surface area of a sphere, a surface area of a sphere equals 4 pi r squared. Four pi r squared. Oops, geez. So that's just going to equal 4 pi times 5 centimeters squared. So that would equal 4 pi times 25 square centimeters. So that would equal 100 pi square centimeters. So that's our surface area. The volume of a sphere equals 4/3 pi r cubed. And once again, in this case, our radius is going to be 5 centimeters. So that's 4/3 pi 5 centimeters cubed. Multiply that out. That's going to be 4/3 pi times 125 cubic centimeters. So that's going to end up being 500 pi over 3 cubic centimeters. And since it's asking us to leave it in pi, that's the best answer. That's the most accurate answer we can get. Right. Question 1b is asking us to find the surface area of the sphere and leave the answer in terms of pi. And I'm sorry, the surface area, let's try that again. Whoops. Okay, so this problem is asking us to find the surface area and the volume of the sphere and to leave our answers in terms of pi. And so to do that, the first thing we need to do is realize that this line right here, that line right there, is a diameter. It goes all the way across the circle. And what we need is the radius. And of course, the radius is going to be 1/2 of the diameter. So if the diameter is 6 feet, the radius is going to be 3 feet. So now using that radius, we can find the surface area of our sphere, because the surface area is equal to 4 pi r squared. So 4 pi r squared. So in this case, that's going to be 4 pi 3 feet squared. So that's going to be 4 pi times 9 square feet, which is going to multiply out to be 36 pi square feet. So the surface area of this sphere is equal to 36 pi square feet. To find the volume, we're going to use the formula for the volume, which is 4/3 pi r cubed, which in this case is going to equal 4/3 pi 3 feet cubed, which is going to equal 4/3 pi times 27 feet cubed, or 27 cubic feet. Okay, the 3 and the 27 can cancel. 3 cancels. This becomes 9. So 9 times 4 would be 36 pi cubic feet. So the volume of this sphere is 36 pi cubic feet, and the surface area of the sphere is 36 pi square feet. So problem number 2, we are given the circumference of a sphere, in this case an orange, and it's asking us to use that to then find the surface area of the orange, and we want to round to the nearest 10. All right, well, we know if the circumference equals 50.24 millimeters, the circumference is equal to 2 pi r. So if the circumference is equal to 50.24 and the circumference is equal to 2 pi r, for the transitive property, they must be equal to each other. So 50.24 millimeters must equal 2 pi r. If I divide both sides by 2, I end up with pi r, or I would end up with, what would that be? That would be 25.12. 25.12 millimeters equals pi r. If I divide both sides by pi, I end up with the fact that r equals 8 millimeters. So now I have my radius. And actually, we'll put that, why don't we put that in red so we can see it. So the radius equals 8 millimeters. Okay. Now it's asking us for the to find the surface area of the orange, and the surface area of any sphere is equal to pi r l. No, it's not just, geez, sorry, I'm losing my mind here. The surface area of a sphere is equal to 4 pi r squared. 4 pi r squared. So in this case, that's going to be equal to 4 pi 8 millimeters squared. So that would equal 4 pi times 64 square millimeters. So that would equal 256 pi square millimeters. But it's asking us to round to the nearest tenth. So if I multiply that out, that would be equal to about, that's about equal to 804.247, and again, it goes forever and ever. So if we want to round that to the nearest tenth, that would be 804.2 square millimeters. Number 3 is asking us to find the volume of a sphere with the surface area of 900 pi meters squared. So, if the surface area of a sphere, which the surface area of a sphere is equal to 4 pi r squared, if that's equal to 900 pi meters squared, then if we divide both sides by 4 pi, we end up that r squared equals 225 meters squared. So r equals 15 meters. Now that we have that, it's relatively easy to figure out the volume, because the volume of a sphere equals 4/3 pi r cubed. By r cubed, which in this case is going to be 4/3 pi times 15 meters cubed. So when I do that whole thing out and multiply it all out and divide, it's going to end up being 4,500 pi cubic meters. That is going to be the volume of my sphere. All right, so this problem is asking us to find a spherical ball of ice cream, a sphere of ice cream in an ice cream cone, and it's asking what percentage of the ice cream cone is filled up by the ice cream if the ice cream were to melt. So to do this, we're going to have to find, first we're going to find the volume of the ice cream. Let's draw the ice cream right here. Here's the ice cream, right there. So we're going to find the volume of that. Then we're going to find the volume of the ice cream cone, which is of course right here. There's the ice cream cone. And then we're just going to take the volume of the ice cream over, we're going to take the volume of the ice cream over the volume of the cone, and that's going to get us the percentage. All right, so first let's do the volume of the ice cream. The volume of the ice cream is just the volume of a sphere, which of course is 4/3 pi r squared. 4/3 pi r cubed, excuse me. And it says that the ice cream has a diameter of 4 centimeters. If the diameter is 4 centimeters, then right here the radius is going to be 2 centimeters. So this is going to, the volume of the ice cream is going to be 4/3 pi 2 centimeters cubed. So do that whole thing out, and you're going to get that that's equal to 32/3 pi cubic centimeters. That is the volume of the ice cream. To get the volume of the cone, the volume of the cone is, of course, equal to 1/3 pi RH squared. I'm sorry, R squared H. 1/3 pi R squared H. Okay, well, the radius is, again, if the diameter is 4, the radius is 2. And it tells us the sugar cone is 10 centimeters deep, so the height must be 10 centimeters. And this is going to be 2 centimeters. So do this whole thing out, and I've got 1/3 pi times 2 centimeters squared times 10 centimeters. And if I do this whole thing out and multiply it out, I would get that that's equal to 40 pi over 3 centimeters cubed. And now finally, to find the percentage, which is what it's asking for, the percentage is, again, just going to be the volume of the ice cream. That's going to be just equal to the volume of the ice cream over the volume of the cube, or the volume of the cone, excuse me. So that's going to equal 32/3 pi centimeters cubed. And that whole thing is going to be over 40/3 pi centimeters cubed. All right, so if we were to divide the numerator and the denominator by centimeters cubed, those cancel. By pi, those cancel. If we were to multiply the numerator and the denominator by 3, those cancel. So when I'm all done, I'm just left with 32/40, which equals 0.8, or since it's asking for a percentage, that would be 80%. So when this red ice cream melts and it goes into the cone, it will fill up 80% of the volume of the cone. The ice cream is 80% as big as the volume of the cone.